Talking about data types in R, we have already seen a few of the basic data types used in R. This includes vectors, matrices, data frame, but we have mostly spoken about each of them individually. Let's see how they interact between each other also. So the very basic data type in R is called as vector. So let's create one. So let's give it a type name, say vector, and I'm saying 1 because we're creating one vector, and we intend to create a numerical vector. So obviously if I'm saying let this be a sequence of numbers from 21 to 30, so you can see on this side that it has created an integer vector of size 10 elements, and this is the numbers which we have artificially simulated inside the vector. To view a vector, you can directly just press the name of the vector and it will come on the screen. To access individual element in the vector, you have to give the location. So for example, if I want to see what is the value at the 5th location, I will just be saying vector 1 in box bracket 5. So it should retrieve this value. If anytime when you are working on data, you might not be able to directly see what is the type of the object you are using. Anything in R which holds data within itself is called as an object, and anything which does a transformation on that data is called as a function. So all these objects inclusive of vector, matrices, data frames are basically some kind of data object in R. Now if you want to go ahead and do some operations on this vector, say for example I want to create one more vector wherein I want to say that just subtract this existing vector with the number 2, all I have to do is just say vect 1 minus value 2. Now, what I have done is I have not saved this in any new vector, but incidentally you can do that also. So I can say vect subtracted by the value 2. This reference names you are giving in such way so that we can relate to the same. When you see this vector vect sub 2, from each of these vector elements the value 2 has been actually subtracted, and over here what is happening is vector recycling, because the second vector 2 in itself is a vector, right, but of single element. So when we are doing this operation, we can see that over here the vector would be in this form 21 to 30 minus the second vector would be something like this, repeated 10 times. I'm not counting, assuming that it's reaching to 10. So this is how vector recycling is happening. Had you incidentally passed instead of 2 a vector of size 2, so let's try that also. So let's say you want to create a vector subtracted, so I'm just saying vector subtracted over here, and in this case we are intending to subtract this vector 1 which has 10 elements by a vector of size 2, that means it has only 2 elements. We are creating this at runtime, so C2 comma say 10, or let's make it 0 so that we can actually see the effect of the same. Now when you do this, you will notice that the first element would be subtracted by 2, that's over here. The second element will go unaffected. The reason being that if I just copy this structure over here, so let me copy this just to show you. So this is how the operation will happen internally. So you will be having something like this, wherein the vector recycling will happen over here in this fashion. This is how the operation will happen, because 2 comma 0 is having only 2 elements. This would be recycled to map against the original vector from which you are wanting this to be subtracted. That's how vectors typically work. Supposingly you are given a lot of collection of objects, like there could be vector, matrices, and you want to know, or if you want to do some computation. Basically in R, a specific function might work on a matrix in a different way, on a data frame it might work in a different way, and on a vector it might work in a completely different way. So you need to know what is the basic class of the object, which you can obviously check by calling the function class and just passing these elements over here. So it will tell that, okay, vector 1 is an object of class integer and the type is a basic vector. So we typically call this as an integer vector. These are atomic. So there are two types of data types within any form. One is atomic and one is non-atomic. So an atomic one is where the data type is of similar type, and vectors are specifically about that. Now if we go on to the second object, which is exclusively used, which is basically a matrix, which we use quite often in analytics. For high scale computation, that is the one which is exclusively used because it is very efficient in terms of memory handling. So let's do one thing, let's create this vector 1. So I'm just giving some typical names. So I'm saying vector 1, let this be a sequence of numbers from 21 to 30. Vector 2, let this be a sequence of numbers say from 31 to 40. We are artificially simulating these numbers so that it becomes very easy for us to understand. Because when you actually take up some data, you will have to first go through that data to understand it. So we have three vectors. You can notice over here, vector 1, vector 2, vector 3. They are basically atomic vectors, type integer, right? And then if I want to push all of them into an object, I can now use typical notions like this. So I can say a new object. So let me say new object, allocation sign. I can just say the option like this, matrix, wherein I can pass the data which I want to pass. So let me pass the data. So in this case, I am saying let me concatenate vect underscore 1, vect underscore 2, vect underscore 3. Just pass this basically like this. So you'll see something like this. This is a new object created over here, right? New object 1 to 30. Right? Now you can check the class of this object. It's a matrix. Right? And if you intend to see the content, this is how it is stacked now. Now incidentally, if you want, you can do the same thing over here, but instead of doing it as a matrix, you can say it's a data frame, right, in which you're passing all these elements together. And you'll see that this object structure has changed. Now it has become 10 observation of 3 variables each. If you check the class of this object, it is called as a data frame. Same data but represented in a different way. A data frame typically represents, this has to be a new obj object. A data frame typically replicates what we call as a database. So whenever we extract anything from the external world, say a flat file, an Excel file or anything like that, it typically comes in the form of a data frame. For some reasons, for computation perspective, we might convert one of these objects into something else to increase the speed of processing on the data. So let's say if I want to convert, say, this present data frame into some other object. So let's say this is called as typecasting, wherein I'm converting one object into some other data object, right? So we can do that. So let's say it's a new data frame, or let's say new data matrix as dot matrix. This is a typecasting function where you're just converting this from one form to the another form, and you might say new obj. Now you'll observe that the same object which was referred to as new object, which was basically in a data frame form, We have now converted that into a matrix form, and that's how we can see it over here. You can have a look at this now, but it will take the structure of the data frame obviously, and you will see that instead of being shown in this typical form wherein it was referred as all rows, you can see over here it is referred with a row instance and a column instance also. You have got two dimensions now.